Often, we use mathematical thinking to work through everyday situations. Take this problem. Let's see how algebra can help. 3 friends are organising a taxi ride home. A fare often includes 2 parts. Flagfall. This is a flat fee the driver charges to come to you. On top of the flagfall is the cost per kilometre. This is a charge for every kilometre you travel. There are also rates for different times. Before 11 p.m, this driver charges $10 flagfall plus $2 per kilometre. After 11 p.m, the fee changes to $5 flagfall and $3 per kilometre. The trip is 40 kilometres. Do you think there will be much difference in total cost between the 2 rates? One way to compare these charges is to think of them as algebraic equations. $10 call out plus $2 per kilometre. Call the number of kilometres x. So 10 plus 2x. We multiply x by 2 to reflect the $2 per kilometre, equals y, the fare. After 11 p.m, the fare changes. This equation starts with 5 plus 3x, 3 to reflect $3 per kilometre, equals y. We can compare the equations on a graph. Along the bottom, the x-axis, we have distance in kilometres. Along the side, the y-axis, we have the fare cost in dollars. When x is 0, y equals 10. When x is 10, y equals 30. When x is 20, y equals 50. When x is 30, y equals 70. When x is 40, y equals 90. Following the same steps, we can graph 5 plus 3x equals y. What do you think? Is it worth leaving before 11 p.m? The 3 friends decide to take a taxi before 11 p.m. Nina is dropped off first, going roughly 1/3 of the way. Sammy is next, travelling about 2/3 of the way. Joe goes the whole way to his house. The trip costs $90. How much should each person pay? They could equally share $90 between the 3. You can probably see that each would pay $30. But is that fair? One fairer way to work it out might be to use an equation based on how far each person travelled. Nina thinks of her portion of the ride as x, then Sammy's portion as 2x, and Joe's as 3x. So the equation would be x plus 2x plus 3x equals 90. Nina solves that by simplifying the equation, adding the x's together to get 6x equals 90. She divides each side by 6, leaving x equal to 15. That means Nina pays $15, Sammy pays twice that, which is $30, and Joe pays 3 times 15, which is $45. Both sides of the equation equal 90. Joe comes up with a different approach. He thinks of his share as equal to x. Then Nina should only pay 1/3 of that, and Sammy would pay 2/3 of that. Joe would pay x. So his equation is 1/3 of x plus 2/3 of x plus x equals 90. Try this later. See if Joe's equation works. What would each person pay? Next time you are faced with a dilemma like this, consider what you know and see what's possible using algebraic thinking.